Okay. Now come to the today class. So any doubts from the previous class? No more? Okay. Now today we will discuss one more topic. So after completion of this topic we will stop. Okay. So now suppose here I am assuming here the f is any vector point function. So given a vector point, so vector point function f is any vector point function. Suppose if there exists a scalar point function pi, it is a scalar point function such that if we can write, suppose this f is equal del pi, or say I can write this f is equal the gradient of pi, then this pi is called as the ఏమంటారండి here ఇది వచ్చింది ఆల్రెడీ ఇంతకుముందు ఎప్పుడైనా. So this we called as a scalar potential of vector function f. Okay, so that means our next definition is scalar potential so scalar potential so scalar potential means it is just if the gradient of f is equal to some vector point function, and this pi is called as the scalar potential of the f. And now we will see some properties of this scalar potential. Anyway, it is the only gradient, this problem related to only gradient of f. Now the first properties, we will discuss the properties. Property 1, so first property, suppose here I am taking if pi is scalar potential of f, then what is the vector function f? Now we will check. So we know that here it must be f is equal to the gradient of f, now here I am calculating ఒక్క నిమిషం అండి సరిపోట్లే స్పేస్. Okay, here I am taking here f is equal, we know that f is equal to gradient of f, so gradient of pi. Now here I am calculating the del cross f. What is the del cross of f? Already it is the gradient of pi. What is the gradient of pi? The gradient of pi is I into dou f by dou x and j into dou by dou y plus k into dou by dou z into pi. That means I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. It is the gradient of f. So gradient of f. Now I want to calculate the curl of the vector. So it is the, now what is our f? Now our f is equal to here I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now just I want to find the curl of this vector. Now the curl of f, so I in j k and the dou by dou x, dou by dou y and dou by dou z, sorry z here. Next one, our f vector dou pi by dou x and dou pi by dou y and dou pi by dou z. Just to find the determinant of the matrix, so after solving it is the dou square pi by dou y and dou z, and here dou square pi by dou y dou z minus j into first and last one dou square pi by dou x dou z minus dou square pi by dou x and dou z and first and second plus k into dou square pi by dou x dou y minus dou square pi by dou x dou y. So I into 0 minus j into 0 plus k into 0, so it is entirely 0. What about that mean? Anybody? What is the statement? So this f is now, what is the f? F is now a irrotational vector. Irrotational vector. Very good. So irrotational vector. That is our first statement. The first statement, what is the first statement? The property 1. If suppose pi is any scalar potential of f, definitely then f is always an irrotational vector, is an irrotational vector. Irrotational vector. Now same I am asking the second. What is the converse of this statement? What is the statement? First statement. If pi is scalar potential of f, then definitely f must be irrotational vector. Irrotational vector. Or same statement I can write like this. What is the same statement? F is equal gradient of pi, then definitely curl f must be 0. Or you can write the statement like this: if f is equal to del pi, definitely del cross f must be 0. Or del cross del pi must be 0. Okay. Now what about the converse? Converse of the statement. Converse. Conversely, so converse also it will work. So converse also work means here, suppose if f is if f is an irrotational vector, definitely then there exists a scalar point function, that means a scalar potential pi, such that f must be is equal to del pi. That means the conclusion is this one is the if and only if condition. Okay. If pi is the scalar potential of f, definitely that is irrotation vector. Or if it is the irrotation vector, definitely there exists a scalar potential of that corresponding vector. Okay Nandi? So this is the second point. Okay, so converse is always true. Okay, so next one, third property is property number 3. So property number 3, so property number 3, suppose here I'm taking f is equal, if f is equal f1i plus f2j plus f3k, and I'm assuming pi is a scalar potential function, scalar potential field, then what is the relation between these two? Already we know that what is the relation between these two. Definitely f is equal, we have the gradient of pi. So gradient of pi, that means already it is f is given. So f is equal to f1i plus f2j plus f3k is equal to gradient of pi. That means I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Now after comparison, what we'll get here? f1 is equal to dou pi by dou x, and f2 is equal to dou pi by dou y, and f3 is equal to dou pi by dou z. And before going to this one, now I am asking a question. In the differential equations, what is the definition of the exact differential equation? Exact differential equation. What is the definition of exact differential equation? Gurtunda andi?
Dou m by dou y equals to dou n by dou x.
That is the necessary and sufficient condition for the exact differential equation. Suppose m dx plus n dy is equal to 0 is exact differential equation. Is an exact differential equation. Then condition, if the whole differential equation m dx plus n dy you have to write in the form of some df. Okay Nandi? Gurtunda definition? Gurtunda andi definition? If there exists a f such that df is equal to the m dx plus n dy, the given differential equation we called as exact differential equation. Okay Nandi? Okay, now come to the our problem. Now we know that pi is the function of x, y, z. Now what is the derivative of pi? So derivative of pi we can write dou pi by dou x after differentiating into dx plus dou pi by dou y into dy plus dou pi by dou z into dz. But already we have here the dou pi by dou x and dou pi by dou y and dou pi by dou z is it is the f1 and it is the f2 and it is the f3. That means this total we can write f1 into dx plus f2 into dy plus f3 into dz is equal to d pi. What about this mean? Now here I am writing the question in the reverse. f1 dx plus f2 dy plus f3 dz is equal to, now is it exact differential equation or not? స్టేట్మెంట్ అర్థమైందా అండి? సో ఇన్ ద two variables mdx plus ndy is equal to some df, derivative of f, then the whole differential equation we call as exact differential equation. But here I am adding one more variable, f1 dx plus f2 dy plus f3 dz is equal to, I am writing the d pi. D pi means the whole differential equation we are writing derivative of some function. So what does that mean? So this differential equation now an exact differential equation. Am I clear? Or you get my point? Clear, Andy? Okay, Andy? Hello?
సార్ కొంతమందికి లైవ్ రావట్లేదంట సార్.
లైవ్ రావట్లేదా? ఈ సెకండ్ లింక్ తీసుకోండి ఒకసారి. అయ్యో రామ, ఈ లైవా లేకపోతే ఇది మన గూగుల్ మీటా లేకపోతే యూట్యూబ్ లింకా?
యూట్యూబ్ లింక్ సార్.
యూట్యూబ్ లింక్ ఒకసారి చూడండి. ఏసీఆర్ సాత్వికనా? ఇక్కడ ఎంతమంది ఉన్నారండి గూగుల్ మీట్లో? 100. ఈ సెకండ్ లింక్ తీసుకోండి, ఫస్ట్ లింక్ కాదు. ఆ లింక్ ఓపెన్ అవ్వట్లేదా అండి? ఇక్కడ నెట్వర్క్ స్లో ఉంది, అక్కడ నెట్వర్క్
లైవ్ రావట్లేదండి సార్.
వస్తుంది కదా అండి? హలో, చూస్తున్నారా? సిఆర్ సిఆర్
సార్ సెకండ్ లింక్ షేర్.
సెకండ్ లింక్ షేర్ చేయండి. ఫస్ట్ లింక్ ఏంటంటే అది ఓన్లీ రివ్యూ, సెకండ్ లింక్ ఏంటంటే ఈ క్లాస్. అర్థమైందా సిఆర్?
వస్తుంది సార్.
ఓకే, స్క్రీన్ మీద కనబడుతుందా సెకండ్ లింక్? ఫస్ట్ లింక్ ఏంటి జస్ట్ ఏంటంటే నేను క్లాసు అది రివిజనే, అందుకే సెకండ్ లింక్ తీసుకోండి. ఓకే, క్లియరా? ఓకేనా సిఆర్? ఇప్పుడు ఓకేనా సిఆర్? నేను కొంచెం లోలో మాట్లాడుతున్నాను. క్లాస్ ఓకేనా? ఓకే. సో 2 లింకులు పెట్టాను, మీరు ఏ లింక్ ఓపెన్ చేసినా ఏదో ఒకటి ఓపెన్ అవుతుంది. ఓకే, ఫస్ట్ లింక్ సెకండ్ లింక్ తీసుకోండి. ఓకే, ఇప్పుడు మనం ఎక్కడున్నాం ఏమో. ఓకే, నౌ వాట్ ఈస్ ద హియర్ ద థర్డ్ ప్రాపర్టీ? If f is some vector point function and the pi is the scalar potential of this f, this f, then definitely f1 dx plus f2 dy plus f3 dz must be which type of differential equation? త్వరగా చెప్పాలండి. It is the అయ్యో exact differential equation. Okay, clear? అయ్యో రామా, హలో 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 సిఆర్ వాయిస్ ఓకేనా సిఆర్? Okay, so now come to the third property. So f is the here the vector point function and pi is the scalar potential field of f. Then definitely f1 dx1 plus f2 dx2 plus f3 dxz must be which type of differential equation? This is the exact differential equation. According to the ordinary differential equation, if mdx plus ndy is 0, if it is exact differential equation, definitely there exists a function f. The whole differential equation will write df is equal to mdx plus ndy. So same type of here the result is this whole differential equation we are writing d pi. D pi is equal to f1 dx plus f2 dy plus f3 dz. So this differential equation must be the exact differential equation. Am I clear? Okay. Now come to the next one, fourth property. So fourth property paste. Now the fourth properties I am removing. Now the fourth property, now so we know that here the f1 dx plus f2 dy plus f3 dz is equal to 0 is an exact differential equation. Now I am asking a question, what is the necessary and sufficient condition for this exact differential equation? Am I clear? So you know that this is the exact differential equation, but what is the necessary and sufficient condition for this exact differential equation? That is our fourth statement. So here the f is equal to f1 I plus f2j plus f3k, and pi is the scalar potential field of f. That means the statement we can write this f is equal to gradient of pi. Then we know that this differential equation is the exact differential equation. So we know that this is an exact differential equation. exact differential equation. But what is the necessary and sufficient condition? Necessary and sufficient condition for this exact differential equation. Now we will check. Now what is the statement here? This the given pi is the scalar potential field of f. That means f is equal to gradient of pi. That means I dou pi by dou x directly I am writing plus j dou pi by dou y plus k dou pi by dou z, and this f is, we know that f1i plus f2j plus f3k. After comparison we will get the f1 is equal to dou pi by dou x plus f3 is equal to, f2 is equal to dou pi by dou y, and f3 is equal to dou pi by dou z. Now I am taking the first and second one. Now after differentiating with respect to y, this one will get the dou square pi by dou x into dou y. Now after differentiating with respect to x, this one is dou f2 by dou x. So it is equal. Now similarly I am taking f2 and f3. So after differentiating with respect to z, it is equal dou square pi by dou y dou z. After differentiating with respect to y, we will get the dou f3 by dou y. Similarly from 1 and 2. So from 1 and 2 also we will get the one more equation. The equation is dou f1 by dou z is equal to dou square pi by dou x dou z is equal to dou f3 by dou x. That means the conclusion is, if it is suppose f is the vector point function and pi is the scalar potential of f, and the whole differential equation must be exact differential equation if and only if dou f1 by dou y must be is equal to dou f2 by dou x, and dou f2 by dou z is equal to dou f3 by dou y. Dou f1 by dou z is equal to dou f3 by dou x. So this is the necessary and sufficient condition for this differential equation. Okay, so this is the conclusion. Now we will solve the 3 problems. After 3 problems we will stop our session. Okay Nandi. Now come to the first problem. వినపడుతుందా అండి వాయిస్? ఓకే, సో కొంచెం మీరు రెస్పాండ్ ఇవ్వండి, లేదంటే నెట్వర్క్ ప్రాబ్లం వల్ల మేబీ డిస్కనెక్ట్ అయితే మనకి ఐడెంటిఫై చేయడం కష్టం. జస్ట్ మీరు మధ్యలో రెస్పాన్స్ ఇస్తే నేను నెట్వర్క్ యాక్టివ్లో ఉందని. ఓకే, నౌ కమ్ టు ద ఫస్ట్ ప్రాబ్లం. So the first problem is that, so show that the given f is 2xy plus z cube I plus x square j plus 3z square x k. Show that is irrotational vector. Irrotational vector. Irrotational vector. Can you prove? How can you prove? Just find the only curl f. So 2xy plus z cube into I plus x square j plus 3z square x. Now just we have to prove that curl f or del cross f 0. What is the del cross f here? I, j, k, first row. Second row is dou by dou x, dou by dou y, and dou by dou z. And third row is, what is the third row here? Square here, 3z square x. So here I am writing directly. So I into, what is the result? 0 minus 0. Direct రాయొచ్చండి, ఇంకో స్టెప్ వేయాలా? హలో సిఆర్?
డైరెక్ట్గా రాయాలి సార్.
Okay, direct. So minus j into, what is the determinant of the remaining after differentiating with respect to x? This whole part is 3z square minus, after differentiating with respect, this is also 3z square plus k into, after differentiating with respect to x, it is the 2x. After differentiating with respect to y, it is minus 2x. So I into 0 plus minus j into 0 plus k into 0, that means this whole 0. Whole 0 means, whatever that mean, this f is an irrotational vector. But according to the 1 2, what is the property 1 2? 1 and 2. Property number 1 2. If f is an irrotational vector, definitely there exists a scalar potential. Okay, so now the second question is, so we know that this, the given vector is the irrotational vector, we know that. Now the second question is find. So second question is question number 2 in the sub question, find its scalar potential, its scalar potential field. That means the question is, what is the pi? Okay, and same question they will give like this also. At least the same question. If f is equal to 2xy plus z cube into I plus x square j plus 3z square xk, and f is equal here the gradient of pi, then find the pi value. Okay, so this is the question. Okay, if f is some vector and f is equal to gradient of pi, what is the pi? Okay, now the biggest question is, how can you find the pi? How can you find the pi? So according to the previous statement number 3, what is the statement number 3? Property number 3. So f is the vector and the pi is the scalar potential field of f. Then f1 dx plus f3 dy plus f3 dz, it is the exact differential equation, and the whole differential equation we can write like this. Okay, am I clear? So I am using this statement. So I am using this third statement. Now come to the question. Now here, so it is, now let us consider pi is a scalar potential of field f. That means whatever that statement, so that is equal to, this f is equal to gradient of pi, or f is equal to del pi, both are same meaning. And what is the given f? The given f is, now f is equal to 2xy plus z cube into I plus x square j plus 3z square x into k. So this is our f. Now according to the previous statement, if it is suppose pi is the scalar potential, definitely d pi is equal to dou f by dou pi by dou x into dx plus dou pi by dou y dy plus dou pi by dou z into dz. But already we know that it is the f is the, so pi is the scalar potential. Now the gradient of f, that means f is equal to gradient of pi. So grade pi, and f is equal, what is our f? 2xy plus z cube I plus x square j plus 3z square x into k is equal grade of pi. So I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now after comparison, what will get here? Dou pi by dou x is equal to 2xy plus z cube. Dou pi by dou y is equal to x square, and dou pi by dou y is equal to 3z square x. Now we have the result. That means now here we'll get the dx is equal to, so d pi is equal dou x by dou y. What is this result? 2xy plus z cube into dx plus next one dou pi by dou y, so x square dy plus 3z square x dz. But directly we know that according to the statement number 3, according to the property number 3, what is the property number 3? Directly d pi is equal to f1 dx plus f2 dy plus f3 d3. We can write directly this result. Okay. So directly we will use that result. So this is the our f1, this is the f1, this is the f2, this is the f3. So directly we will write our d pi is equal to f1 dx plus f2 dy plus f3 dz. Okay. Now it is the differential equation, and according to the previous statement we know that this is the exact differential equation. Exact differential equation means just according to the inspection method, just try to solve the problem. So can you solve by using inspection method? Now in this one, come to the first part, and here there is a 2xy, that means it is the combination of x and y. That means we have to club this dx and dy. So after adding, so 2xy dx plus x square dy. So it is the first part. So first of all, try to solve this problem. Can we solve? Now in this one, just you have to use the derivative of a into b. What is the derivative of a into b? A into derivative of b plus b into derivative of a. It is the product rule, and the addition rule is derivative of a plus b, derivative of a plus derivative of b, and subtraction rule, derivative of a minus b is derivative of a minus derivative of b, and the division rule, derivative of a by b is b into derivative of a minus a into derivative of b by b square. Okay. So in this one, here I am using the product rule. Here there is a x square dy. So x square dy means we can, this 2x into dx, we can write like this: y into derivative of x square plus x square dy. According to the derivative law, so we can write derivative of x square y. Okay, that means this first part and third part we can write derivative of x square into y. Now come to the second and third one. What is the second and third one? So second and third one, here the z into dx plus 3z square x into dz. So already here there is a z cube into dx. Now in this part, this 3z square and dz you have to club. So we can easily club. So that is a z cube dx plus x into, we can write derivative of z cube. According to the product rule, we can write derivative of x into z cube. And according to the additive rule, Now we will write this whole is derivative of x square y plus x z cube is equal to d pi. That means after integrating on both sides we will get the pi is equal to x square y plus x z cube plus some constant. So now this is our scalar potential of the given vector field is the scalar potential of the given f. Okay. Now how can you verify? What is the verification? Can we verify? Verify cheyandi. Verification. So verification is easy. So already we are getting the pi. Scalar potential is, what is the scalar potential is? X square y x z cube. So x square y and x z cube plus constant. Now from this one just find the gradient of f. What is the f? Already we know the f. Now just find the f is equal to gradient of pi. So gradient of pi means I dou x by dou pi and j dou x by dou y plus k dou x dou by dou into pi x square y plus x z cube plus constant. Now differentiate with respect to x. Here we will get the I into 2xy plus z cube first one plus j into differentiate with respect to y. We will get the x square plus k into differentiate with respect to z 3z square x. We will get the answer. Okay, this is the verification. Am I clear? Like that you can easily verify whether your result is wrong or right. So like that you have to verify. Clear, Andy? Okay.
Okay, sir.
Okay, next one we will solve 2 more problems, then we will stop. Okay, so same type of problems. So don't confuse. Now come to the second question, same type of question. Now assume if f is equal x y square plus y cube I plus x square y plus 3xy square first one show that this is the irrotational vector, because if it is an irrotational vector definitely there is a scalar potential irrotational vector and thus in this one second question, and also find its scalar potential. So potential of this f. Okay, anyway first of all we will verify. What is the verification? Now the just we have to prove that curl f. So curl f, so I am writing directly. What is the curl f? I, j, k, first row. Second row is dou by dou x, dou by dou y and dou by dou z. And what is the third row here? Third row is x y square plus y cube and x square y plus 3xy square and 0. Now I into, so derivative 0 and it is without z 0 minus j into after differentiating with respect to x it is 0 minus it is without 0 plus k into, and after differentiating with respect to x we will get the 2xy plus 3y square minus after differentiating with respect to y 2xy plus 3y square. So now this is entirely 0. So entirely 0 means the given function f is, this f is an irrotational vector. Irrotational irrotational vector. Next one, you have to find the its scalar potential. So finding the scalar potential. Now let assume pi is scalar potential of f. Then what is the statement? This f is equal to gradient of pi. And one more, what is the previous statement? Directly, definitely d pi must be is equal to f1 dx plus f2 dy f3 dz. I am not writing all, directly I am writing the results. So d pi is equal to f1 dx plus f2 dy plus f3 dz. Now what is our f in the given vector? What is the given vector? F is equal, what is the given vector? Vector ఏమి ఇచ్చారండి? x y square plus y cube I plus x square y plus 3xy square into j plus k into 0. Now what is our f here? Our f is, this is the f1, this is the f2 and this is the f3. f1i plus f2j plus f3k. Okay, now substitute directly all the values. After substituting f1, so x y square plus y cube into dx plus x square y plus 3xy square into dy plus 0 into dz. Now we have to adjust the functions. What is the adjustment? Now come to here, this is the first term and in the third term. Here there is a xy square and here x square y. So in this two we can club these two. So xy square dx plus x square y dy. In this one there is a x into y common, then it is the y into dx plus x into dy. According to the product rule, we can write it is the derivative of x into y. Okay, and moreover we can write this part is derivative of, okay, వద్దులేండి. So derivative of, okay, now it is the first one. Now come to the second one. In the second part, that means this y cube into dx plus 3xy square into dy, and already here there is a y cube into dx. Next one, in the second part we have to write x into derivative of y cube, that means here the 3 and this dy square dy, we can write it is x into derivative of y cube. So y cube dx. So after using the product rule, derivative of x into y cube. So after using the integration, so it is entirely d pi only, d pi. Now after integration of this whole, what is the, after integration of this one, we will get the pi is equal integration of this x into y, xy whole square by 2 plus xy cube plus constant. It is our scalar potential function. So this is the our scalar potential function. Scalar potential of f. And we can easily verify also. What is the verification? That is a very easy verification. What is our pi? Our pi is equal to xy square by 2 plus xy cube plus constant. Already we know the f. Now f is equal to gradient of pi. That means I into dou pi by I into dou pi by dou x and j into dou by dou y plus k into dou by dou z into what is our pi function? Our pi function is xy whole square by 2 plus xy cube plus constant. Now after differentiating with respect to only x, what will get the result here? The result is 2 will cancel, xy square and here y cube only. After differentiating with respect to y, here we will get the x square y and here we will get the 3xy square plus 0. It will match. Match అవుతుందా అండి? Match. So our answer is correct. Okay Nandi? So like that you can easily verify. Okay, now we will see the one more problem. This is the last problem in this session, then we will stop. Okay, third one. So third one is, it is not direct problem, this is the little bit indirect problem. So it is the clearly given, find the component lambda so that f is an irrotational vector field where f is lambda xy minus z cube into I plus lambda minus 2 into x square j plus 1 minus lambda into x z square into k. So lambda solve చేయొచ్చండి ఈజీగా. So compared to the previous two problems, this is the they have given it is clearly irrotational vector. We have to find the unknown. Now, so first of all you have to assume the given vector is already is clearly given irrotational vector, irrotational vector field. That means you have to assume curl del cross f must be 0. That means curl f 0. That means the determinant of I, k, first row, second row is dou by dou x, dou by dou y and dou by dou z, and third row is, what is the third row? Lambda x y minus z cube and the lambda minus 2 into x square and 1 minus lambda into x z square is equal, we have to assume 0 because it is clearly given this is an irrotational vector. Now I into, ఎవరైనా సాల్వ్ చేస్తారని lambda value త్వరగా, I will give the 2 minutes. 2 minutes లో సాల్వ్ చేయండి. what is the lambda value? వచ్చిందా ఆన్సర్? ఓకేనా? lambda value hello, anybody? lambda value. Okay, anybody ఉన్నారండి లైన్లో? ఫోర్ స్వాతి గుడ్ ఫ్రమ్ C1. ఓకే, ఇంకెవరికైనా వచ్చిందా ఆన్సర్? C1 వాళ్ళు ఎవరు సాల్వ్ చేశారు? ఓకే, ఇంకెవరు సాల్వ్ చేశారు? ఓకే, ఇంకా ఫ్రమ్ C4.
lambda equal to 4.
From C4, okay. Varshita, very good. Okay, so if lambda is equal to 4, so this is an irrotation vector. Okay, so and try to solve. Okay, so ఎవరైతే సాల్వ్ చేశారో మీరు ఇది సాల్వ్ చేసేయండి అండ్ ఆల్సో ఫైండ్ its scalar potential of f. Okay, so may try చేయండి ఆ లోపు మీ సాల్వ్ చేస్తాం. సో lambda is 4, very good. Now after differentiating with respect to y it is 0 minus, after differentiating with respect it is also 0 minus j into, after differentiating with respect to x 1 minus lambda into z square minus, after differentiating with respect to z it is minus 3 z square plus k. After differentiating with respect to x it is the lambda minus 2 into 2x. After differentiating with respect to y minus lambda x is equal 0. Now 0, now equation I into 0 minus j, so 1 minus lambda, so plus 3 into z square, first one, plus k into, so x is common, after separating the x we will get the 2 lambda minus 4 minus 1 into x is equal to 0. So I into 0 minus j, so 4 minus lambda into z square plus k into, ఒక్క నిమిషం అండి, oh sorry, here lambda, sorry. So lambda minus 4 into x is equal to 0. So anyway it is the equal to 0 vector. Now 4 minus lambda must be 0. Now the lambda is equal to 4. If the lambda is equal to 4, this is an irrotation vector. Next question is, and also find its scalar potential. So scalar potential first, but first of all what about our vector f? So we have to write the full vector. Now the lambda is equal to 4, lambda is equal to 4, our vector f is, what is the given vector? Lambda xy minus z cube into I plus lambda minus 2 x square j plus 1 minus lambda into x z square k. After substituting lambda is equal to 4, our vector is 4xy minus z cube I plus 2x square j minus 3x z square k. So this is the our vector. This is the irrotation vector. Is an irrotation vector. Is an irrotational vector. Okay, in this one we know that this is the f1 and this is the f2 and it is the f3. Okay, directly we will solve. Now let us assume pi is scalar potential of f, and our f is in the form of f1 I plus f2 j plus f3 k, and scalar potential means definitely f must be is equal to gradient of pi and our f or d pi must be is equal to f1 dx plus f2 dy plus f3 dz according to the necessary and sufficient condition. Now what is the f1? d pi is equal to d pi is equal to 4xy minus z cube into dx plus f2 is 2x square dy minus f3, so minus 3x z square into dz. Now come to the first one, 4xy. So 4xy means we have to club x and y. So without combining x and y we cannot. That means this first term and third term, these two we have to join, otherwise we cannot. Now we'll join first of all this one. Now after joining, what is the result? The result here, color, okay, red color is better. Now 4xy plus 2x square dy. So already here there is a 2x square. So here we can write, sorry, okay, so 4xy dx plus 2x square dy. Now the first part I can write, it is y into derivative of x square. So y into 2x square plus this is again 2x square dy. That means the whole part I can write derivative of 2x square y. Now it is okay. Next one, come to the here this one and this one, it is the combination of x, it is the combination of x and z. Now the first one is the minus z cube dx minus 3x z square into dz. Now minus is common, so minus of z cube dx minus surplus 3x z square into dz. All here there is a z cube dx. Here also we have to form x derivative of z cube. We can easily form. So z cube dx plus this one I can write x into derivative of z cube, because here there is a 3 and here there is a z square and here there is a dz. We can club. Now this whole part I can write according to the product rule to derivative of x into z cube, and already here we have derivative of, oh my god, so derivative of 2x square y, and left hand side there is a d pi. So after integrating, that means now it is the exact differential equation, because the whole differential equation we are writing derivative of some function. Now what is our pi now? Our pi is equal, pi function is 2x square y minus x z cube plus constant. Or you can write like this also. You can write like this. How? So derivative of according to the subtraction rule. So 2x square y minus x z cube is equal d pi. Now integrate. After integrating we will get the pi is equal to 2x square y minus x z cube plus constant. Now come to the verification. We will verify same. What is our pi? Our pi is equal, blue better, okay. Pi is equal to 2x square y minus x z cube plus constant. Verification. verification. Now just find the gradient of pi. What is our f? F is equal to gradient of pi. That means I dou by dou x dou y plus k dou by dou z into pi. Now pi, that means after differentiating with respect to dou pi by dou x, j dou pi by dou y and plus dou pi by dou z. After differentiating with respect to x, what we will get here? 4xy minus z cube plus after differentiating with respect to y, 2x square only. After differentiating with respect to 2, minus 3xz square. So match. So this is the verification. Okay nandi? ఎవరికైనా ఆన్సర్ వచ్చిందండి? సాల్వ్ చేశారా ముందే? ఎనీబడి? అక్షయ, వర్షిత, హారిక, స్వాతి? ఎస్ స్వాతి. ఓకే, ఇంకా ఇంకెంతమందికి వచ్చింది? జస్ట్ గివ్ మీ ద కామెంట్. మనోజ్ ఓకే, అక్షయ, వెన్నెల, వర్షిత, అశ్రిత, మహేశ్వరి, హారిక, అనూష. ఓకే, మహేశ్వర రెడ్డి, వెరీ గుడ్. ఓకే ఓకే, సో ఐఎమ్ గివింగ్ ద homework problems, just to try to solve the problems. Okay, now the first problem is, I think this problem already I have given in the previous class. సో ప్రీవియస్ క్లాస్ లాస్ట్ ప్రాబ్లం ఏమైంది గుర్తుందా అండి? ఒకటి ఇచ్చిన ఎఫ్ ఈజ్ ఈక్వల్ టు ఎక్స్ క్యూబ్ ప్లస్ వై క్యూబ్ ప్లస్ జెడ్ క్యూబ్ మైనస్ 3xyz. గుర్తుందా అండి? ఫైండ్ ద ఎఫ్ ఈజ్ ఈక్వల్ గ్రేడియంట్ ఆఫ్ పై. ఇదేనండి క్వశ్చన్.
Yes, sir.
Okay, now I am giving the question reverse, and moreover here the curl f must be 0. Curl f 0 వచ్చినట్టు ఉంది ఈ ప్రాబ్లం కి. 0 వచ్చిందా? అండ్ div f ఏమొచ్చింది? del dot f ఏమొచ్చింది? 6 of x plus y plus z. Okay, now we will solve the same problem in the different manner. So different manner means, what is our f here? If f is equal to, what is the f here? F is equal to 3x square minus 3yz I plus 3y square minus 3xz j plus 3z square minus 3xy k. ఫస్ట్ క్వశ్చన్ ఏముంటుందండి? షో దట్ దిస్ ఈజ్ అన్ irrotation vector, but already we know the result. ఇది లాస్ట్ క్లాస్లో సాల్వ్ చేసినట్టున్నాం. అండ్ ఆల్సో ఫైండ్ ఇట్స్ స్కేలార్ పొటెన్షియల్. ఆన్సర్ ఏమొస్తుందండి? దిస్ ఈజ్ ద ఆన్సర్. సో ఇక్కడ ఆన్సర్ ఉంది ఎక్స్ క్యూబ్ ప్లస్ వై క్యూబ్ ప్లస్ మైనస్ 3xyz. సో ఇది ఆన్సర్ అండి. సో దట్ ఈస్ ద వెరిఫికేషన్. ఇంకా లాస్ట్ క్లాస్లో కొన్ని ప్రాబ్లమ్స్ ఇచ్చినట్టున్నాను సోలనాయిడ్ అండ్కి ఇరోటేషన్ వెక్టర్స్కి. గుర్తున్నాయండి? ఏ ప్రాబ్లమ్స్ ఇచ్చినట్టున్నాను?
Yes, sir. గుర్తుంది.
అదే రాస్తున్నాను. సెకండ్ ప్రాబ్లం ఇది మేబీ లాస్ట్ క్లాస్లో ఇచ్చాను. f is equal, show that this f is equal to 2x plus yz I plus 4y plus j minus 6z minus xy. ఈ సాల్వ్ చేసామా? మీకు హోంవర్క్ ఇచ్చాను ఇది.
Homework problem, sir.
Okay, and this structure always it gives the solenoid as well as show that this is solenoidal and irrotation vector, but we are in what is our topic? క్వశ్చన్ ఏంటి? మన క్వశ్చన్ ఇక్కడ ఏముంటుందండి? అండ్ ఆల్సో ఫైండ్ ఇట్స్ స్కేలార్ పొటెన్షియల్ ఆఫ్ దిస్ ఎఫ్. సో ఆల్రెడీ 2 ప్రాబ్లమ్స్ మీరు సాల్వ్ చేశారు. దిస్ ఈజ్ ద అడిషన్. జస్ట్ ఫైండ్ ఇట్స్ స్కేలార్ పొటెన్షియల్. ఓకే, నెక్స్ట్ వన్. ఇంకొక ప్రాబ్లం ఇచ్చినట్టున్నాను ఈ రొటేషన్ వెక్టర్లో. థర్డ్ వన్, prove that f is equal, now the f is y square cos x plus z cube I plus 2y sin x minus 2j plus 3x z square. ఈ ప్రాబ్లం సాల్వ్ చేస్తారా? గుర్తుందా? షో దట్ ఈజ్ an irrotational vector and question ఏముంటుందండి? and also find its scalar potential of f. ఈ 3 ప్రాబ్లమ్స్ సాల్వ్ చేయండి చాలు. ఓకేనా అండి? ఓకే
ఓకే సార్.
ఓకే. C1 సరే, C3 C4 వాళ్ళు ఉన్నారా అండి?
ఎస్ సార్.
C1 C2 వాళ్ళు ఉన్నారండి? ఎవరైనా ఉన్నారా? సాత్విక, నాగరాజు. ఓకే, సో ఎనీవే నా విల్ స్టాప్. ఇంకా డౌట్స్ ఉంటే అడగచ్చా అండి ఈ సెషన్లో? డౌట్స్ ఉన్నాయా? డౌట్స్ ఉన్నాయా అండి? ఉన్నాయా లేవా? ఓకే, సో ఎవరైనా క్లాస్ మిస్ అయితే అది లింక్ పెడతానండి, ఒకసారి చూడండి. ఓకేనా అండి? మీకు మెటీరియల్ పోస్ట్ చేయండి వద్దా? ఈ రన్నింగ్ నోట్స్
పోస్ట్ చేయండి సార్.
ఏంటి సార్?
మీరు రాయట్లేదా అండి?
అంటే కొన్ని మిస్ అవుతున్నాయి సార్, అందుకే చూసి.
నేను స్లోగానే వెళ్తున్నా అండి, స్పీడ్గా వెళ్ళట్లేదు కాదు. ఆల్రెడీ నేను కూడా రాస్తున్నాను కదా, నాతో పాటు రాయొచ్చు కదండి. ఓకే సర్లేండి, షేర్ చేస్తానండి. ఓకే సరే, డాక్యుమెంట్ చేసి మీకు సెండ్ చేస్తాను. ఓకే, థ్యాంక్ యూ. నా విల్ స్టాప్.
సార్
హోంవర్క్ చెప్.
హోంవర్క్ ప్రాబ్లం 1లో x³ + y³ అదేనా సార్, లేదంటే x² y² సార్?
ఏదండి? ఎక్కడ? ఇప్పుడా అండి?
ఎస్ సార్.
x³ ప్లస్ ఆన్సర్ x³ + y³ + z³ - 3x. ఇది ఆన్సర్ అండి, ఇవి ఆన్సర్స్.
అది అంటే లాస్ట్
ఇది మనకి లాస్ట్ ప్రాబ్లం అదే కదండి, లాస్ట్ ప్రాబ్లం. సో లాస్ట్ క్లాస్లో ఏమి ఇచ్చాను ప్రాబ్లమ్స్? ఎక్కడ ఇచ్చానో ఏమో.
ఆ క్వశ్చన్ x² + y² అని ఉంది సార్.
x² అని రాశాను. కర్లే కదా. ఇదేనండి, ఇది x³ అండి. ఈ ప్రాబ్లం అండి, ఇదే ప్రాబ్లం కదా. సో ఇదే ప్రాబ్లం నేను మళ్ళీ ఇప్పుడు ఇచ్చాను. ఇక్కడ సెకండ్ ప్రాబ్లం ఉంది కదండి,
ఎస్ సార్.
ఇదే ప్రాబ్లం ఇప్పుడు మళ్ళీ ఇచ్చాను. ఓకే,
ఓకే సార్.
క్యాపిటల్ F ఈజ్ ఈక్వల్ 3x² - 3yzi ప్లస్ 3y² - 2xj ప్లస్ 3z² - ఇక్కడ 3xy ఇంటూ k. సో ఇది ఇచ్చాను, జస్ట్ ఎఫ్ సాల్వ్ చేయాలి. సో హియర్ అవర్ స్కేలార్ పొటెన్షియల్ ఈజ్ x³. ఇట్ x³ అండి, ఇక్కడ ఇట్ ఈస్ ద x³ ప్లస్ వై క్యూబ్ ప్లస్ జెడ్ క్యూబ్ మైనస్ 3xyz సాల్వ్ చేస్తే వచ్చేస్తుంది. ఎందుకంటే మనకు ఆల్రెడీ రిజల్ట్స్ తెలుసు కాబట్టి ఈజీగా వచ్చేస్తుంది. ఓకే, మీకు ఆల్రెడీ ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్లో మనకి ఏది ఇన్స్పెక్షన్ మెథడ్ ఉంది, గుర్తుందా అండి?
ఎస్ సార్.
సో అక్కడ 2 వేరియబుల్స్ సాల్వ్ చేస్తుంది, ఇక్కడ 3 వేరియబుల్స్ సాల్వ్ చేయండి, ఈజీగా అయిపోతుంది. అక్కడ బేసిక్ రూల్స్ అని అప్లై చేసేయండి, ఈజీగా అయిపోతుంది. ఓకేనా అండి?
ఓకే సార్.
ఓకే, నౌ విల్ స్టాప్ నౌ. సో థ్యాంక్ యూ టు ఆల్. అటెండెన్స్ అందరు ఇస్తున్నారా అండి ఆన్లైన్లో?
ఎస్ సార్.
ఈరోజు ఎంతమంది ప్రజెంట్ అయ్యారో ఒకసారి చూద్దామండి. వెరిఫై ఎంతమంది వచ్చారో ఏమో. చూస్తున్నారా సిఆర్? ఏ సిఆర్ చూస్తున్నారేమో? C1 39, C2 36, C3 44, C4 48. మై గాడ్, C4 వాళ్ళు ఎక్కువ ఉన్నారు. ఓకే, C2 వాళ్ళకి ఇన్ఫర్మేషన్ లేదా అండి? C2 వాళ్ళకి
ఉంది సార్.
ఓకే.
కొంతమంది యూట్యూబ్ వింటున్నారు సార్.
ఓహో, యూట్యూబ్లో వినండి అండి. కాకపోతే ఇక్కడ కనీసం మీరు ప్రజెంట్ అయినట్టు కొంచెం అటెండెన్స్ ఇస్తే ఏమవుతుందా అండి? ఓకే, మీరు ఎవరైతే లాగిన్ అయ్యారో ఇక్కడ ఖచ్చితంగా ఇక్కడ రికార్డ్ అవుతుందండి. ఓకే, గుర్తుందా అండి? ఇక్కడ ఇందులో ఈరోజు ఎవరు మిస్ అయ్యారంటే వీళ్ళందరూ ఈరోజు మిస్ అయిన వాళ్ళు నేమ్స్ శిరీష, సిద్ధార్థ్, హాసిని, అరుణ్, మేఘన, శివ, వర్షిత డి అండ్ యోగి, हर्षिता जी, श्रावणी जी, अश्विनी जी, ज्योति जी, वैष्णवी जी, विद्या जी, सर दिव्या जी, सौगंधिका जी, राजेंद्र जी, कल्पना जी, अश्विता जी एंड वंशी H, आकाश जे, भावना जे, अनुषा जे, सुजल के, पूजिता के, आली के, మణిచరణ్ కే, కావ్య. సో వీళ్ళందరూ లాగిన్ అవ్వలేదు. ఓకే,
సార్ నేను అయింది సార్. హర్షిత
మరి ఏంటంటే ఇక్కడ రావట్లేదండి?
క్లాస్ విన్నా సార్.
ఓకే, ఓకే, క్లాస్ వినండి. కాకపోతే అందులో అటెండెన్స్ కొంచెం మీరు క్లిక్ చేయండి.
కూడా ఇచ్చాను సార్.
ఇచ్చారు ఇవ్వలేదా?
ఇచ్చాను సార్.
మళ్ళీ ఇవ్వండి, ఒకసారి మళ్ళీ వెరిఫై చేసుకోండి.
ఓకే సార్.
ఓకే, మీ పేరేంటండి?
హర్షిత సార్. జీ పెద్ద
జే ఇనిషియల్
జీ జీ
జీ జీ జీ హర్షిత, జీ హర్షిత.
ఎస్ సార్.
మీరు ఇవ్వలేదండి, అసైన్ అయ్యారు కానీ ఇక్కడ క్లిక్ చేయలేదు అంటున్నారు. ఓకే, మీది ఏ క్లాసు ఆ క్లాసు మీద క్లిక్ చేయండి. ఓకే, C1 C2 C3 వింటున్నారండి? ఓకే, మీరు క్లిక్ చేయండి. సో క్లిక్ చేస్తే ఆటోమేటిక్గా మీది మీరు ఏ క్లాసో ఆ క్లాస్కి మీరు రిజిస్టర్ అవుతారు. ఓకే, సో థ్యాంక్ యూ. ఐ విల్ స్టాప్ నౌ. థ్యాంక్ యూ టు ఆల్.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ.